Algebras. Welcome to your Chapter 14 overview and your Chapter 14 Lesson 1 notes. So, Chapter 14 is all about two variables of data and comparing how those two variables of data might interact with each other. Maybe looking at, does one cause the other to happen? Maybe look at, is there some sort of relationship between these two variables worth of data? Okay, and so what we're going to do here is first we're just going to review what we did back in chapter 2 when we looked at one variable of data, and we're going to look back at all the graphs that we did and all the analysis that we did, mean, median, mode, and range and interquartile range and all that good stuff, right? That's what we'll do today in lesson 1. But then we're immediately going to add a second layer, a second variable worth of data tomorrow, and talk about what scatter plots are and how that's how we can visually compare these two sets of data using an XY axis. Okay, then we'll talk about what it means to have a linear regression, and we'll use that to help us in a lab setting here, getting ready for our quiz for chapter 14. And then we're going to talk about exponential regressions. So we'll have linear regressions and exponential regressions in this chapter. Okay, that's what we'll kind of look at. Residuals is something that we'll glance over, and then we've got these two-way frequency tables that you did in 8th grade. We'll review what that looks like. It's a little bit different way to look at some variables and categories. Yeah, this is a lot of fun. A lot of graphing calculator work, very heavy on our graphing calculator in this chapter. So just kind of be prepared for that, okay? So let's look at our first lesson where we're going to review mean, median, mode, our 5-number summary, range, interquartile range, and standard deviation. So these are some of the main vocabulary terms from chapter 2. Some of the main pieces that we looked at in chapter 2. A mean is your average of your data set, while the median is your actual middle data value. The mode is the data value that appears most often. Those are what we refer to as our measures of central tendency. Your 5-number summary is your minimum data value, your Q1 value, which is the median of the bottom half of the data, your actual median of the data, your Q3, which is your median of your top half of your data, and your maximum. That's your 5-number summary. We use that in a box plot, as we remember. The range is subtracting your max minus your min, and the IQR, or interquartile range, is just looking at your inside quartiles. So that subtracts your data from Q3 minus Q1. Okay, so your top half median minus your bottom half median, those give you your interquartile range. That's the middle 50% of the data in the box of the box plot. So if you recall, we also had 3 main types of plots that we looked at: a dot plot, a histogram, and a box plot. A dot plot, of course, is just a literal dot of every single piece of data that you have on a scaled number line. A histogram goes by intervals, very specified intervals, and how often does a data value fall into that interval? That's the frequency up the y-axis. And then, of course, your box plot is on a scaled number line. It puts the 5-number summary into a picture. That's what the box plot does. Okay, and each of the sections is worth 25% of the data. So let's remind ourselves about using the graphing calculator. Here's a page that's right in your notes from chapter 2. It appears in chapter 2. I've just copied and put it right back over here. I'm actually going to do this with a data set on the following page. So this page is for your reference when you're using a graphing calculator without me. It tells you exactly what buttons to press, what to enter, how to check it, how to look for 1var stats, how to look at each of the types of data that comes out of 1var stats. What does all of this mean when I press 1var stats for my data? Okay, so that talks to you about how to do that. But in practice, what we're going to do right now is we are actually going to take this list of 24 popular McDonald's menu items, and we're going to put their grams of fat into our graphing calculator, and we are going to run one var stats on them. So what I want us to do right here is I'm going to have it pause and I'm going to enter the data rather than taking up video time to do that. I want you to make sure you pause and enter the data into L1 on your graphing calculator. And before I do pause, let me just remind you where L1 is on your graphing calculator. Okay. So here's my graphing calculator. I press Stat, and Edit is already highlighted. So you can press 1 or Enter. Here's where you find L1, and this is where you put your data. So 29, Enter, gets you to the next spot, and then 26, Enter, and so on. So this is where I'll pause it, enter my data, you finish entering your data, and we'll come back and work with the data together. Okay, so here is my list with all my data in it, full. I know that I've got 24 pieces of data in this list because right now it is asking for the 25th piece of data. It's highlighted right here, asking for it, but there isn't one. So that's how I know for a fact that there are 24 pieces of data in here. One of the things that I do like to do is just glance over my list compared to the data to make sure it does look accurate. Make sure I didn't type in something wrong. It does look like the data on my list, that how it's supposed to look. Okay, so I just glanced through that real quick to make sure. Yep, okay, looks about right. So now what we do is we press Stat, and notice we've got Calc over here to the right, so I arrow right. And notice one var stats is the first thing and already highlighted, so I can either press 1 or Enter to get into one var stats. Now, right now, my one var stats is asking me for my list, and I did enter my data in list 1, so I do not have to change this. Okay, so now all I have to do is arrow down so that Calculate is highlighted and press Enter, and I get spit out with all of the information that I need for one var stats, okay? X bar is your mean or your average. N is your number of data values. That's 24, just like we knew. We knew 24 popular McDonald's menu items. Your minimum is 7, your Q1 is 15, your median is 22, and your Q3 is 26, your max is 56. So these last 5 are your 5-number summary to create your box plot. Okay? So these are the things that I'm going to write down. And notice I'm arrowing up and down to get from one side of the list to the next. Okay, so let me just make my graphing calculator a little bit smaller again. Okay, so we can start to copy this down. Scooch this up so you can see where I'm talking about. Using one var stats, let's copy these down. So let's copy the mean, which is 22.375. Oh, I did skip over SX when I was explaining. The SX is, of course, the standard deviation, and we do not round the standard deviation unless otherwise told to. So I'm not going to round that. N equals my number of data values, 24. My minimum is 7. My Q1 is 15. And now let me arrow down so I can get my median. Okay, is 22. My Q3 is 26, and my max is 56. Wow, I wonder if that's an outlier. We should probably check that. The range is the max, 56, minus the min, which is 7. So the range, oops, thought I pressed 7, I'm sorry. 56 minus 7. The range is 49. And the IQR is the Q3, which is 26, minus the Q1, which is 15. So that's how I know what my IQR is, or my interquartile range. To check for an outlier, I take my interquartile range, which is, we know, is just 11, and I multiply that by 1.5. This value, 16.5, gets added to the top IQR value, the Q3, and gets subtracted from the bottom IQR value, which is 15. And anything within that, outside of that area, is an outlier. So it's possible that my max is an outlier. Okay. So what I'm going to do right now is I'm just going to take my 15 and I'm going to subtract this 16.5 from it to see if there's a bottom outlier. Oh, right. I wouldn't have negative fat grams. So there can't be a bottom outlier because of that. Okay, that's fine. Now what we do is we add it to 26 to see if there's a top outlier. So let's add 16.5 to 26 and see if there's a top outlier. Is our maximum above 42.5? Yes. If that's the case, that means it's no longer our maximum, because everything above 42.5 is an outlier. Okay, so now what we need to do is we actually need to go back to our data and we need to find any data value that's above 42 and a half. And actually, I see that both my 56 and my 48 are both outliers. So now that I've got those as outliers, I need to look for the next biggest data value. And that's where I come up with 29 here and here. The fish fillet and the Big Mac have 29 grams of fat. That means that 29 value is my new max. Okay, that's what that means. And I will show you a way to check that on your graphing calculator in a minute. So this means that 29 is going to be the max I use when I put this on my dot plot and box plot. Okay? So let's create a histogram first. We are now done with the graphing calculator for the time being. So I'm just going to scooch this off to the side and create a histogram first. Okay, so when creating a histogram, the first thing you have to do is tally how many of your data values fall into each of these categories and then count that up as frequency. That's the first thing you need to do. So I'm going to pause it here and have you tally up, and then we'll check, make sure we get the same frequencies together, and then we'll graph on the histogram. Okay, so you try this, and then we'll do this together on the histogram. Okay, so make sure you check your frequencies. So as I was tallying, I crossed off how I was counting, what I counted in each of my sections. So I made sure I got all of my data values. And then at the end, I also counted up all my frequency numbers and got 24 data values. So I just kind of double checked, making sure I got these correct as I went, right? So now what this means is I've got all these intervals. And by the way, doesn't this look like outliers, right? Like we've already determined. It really does look like outliers. So now I've got all these intervals. I've got to fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 intervals across here. So how many places do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 divided by 11 will give me how thick my intervals maybe should be, because I have 11 intervals, right? And just in case you can't see that, 2.3. So that means I can't make them bigger than 2. So that means my intervals are going to be 2 spaces wide. Now, am I starting at 0? No. So I also need to insert a break. So now I start with my break, and then I can do each of my intervals 2 squares wide across the bottom. 5 to 9 is my first one. And again, it didn't start with 0, so that's why I must have a break. And then 10 to 14, 15 to 19, and I'm just copying these from the interval side. 20 to 24, 25 to 29, and notice that as soon as one interval ends, the other one begins. That's why they're all touching. Okay, so they must touch. They must have the same number of things potentially in them. So all of them have 5 potential data values in them. That's where we get that amount from. And then even these ones that don't have anything do need to be written down, even though they don't have any data values in them, because that just helps us. I got to 45 to 49, 50 to 54, that's 55 to 59. There we go. That helps us to see that those really are like way away from the norm as far as our fat grams for these McDonald's menu items go. Okay. So what I'm going to do now is I'm going to count up the side over on this side right here. And I'm just going to see, I need to make a total of 8 up for my frequency. So let's see how many we have going up the side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I go by twos, my top bar will be hitting the top side. And that's okay. I think that's perfect. So I'm going to go by twos, filling up my chart. There we go. So now when I make my bars, I need to make sure I'm using a straight edge. So the side of a binder, the side of a ruler, the side of a phone, the side of a calculator, whatever it may be, you need to make sure you're using a straight edge of some kind. And then I'll do all my labels at the end. So here's my frequency table. Here, you know what? I'll do this so you can see my frequency table. Zoom out just slightly. And 5 to 9 goes all the way up to 3. So I'm just going to put dots at the 3 on each side. 10 to 14 goes to 2. So I'll put those up there. 15 to 19 goes all the way up to 6. Then 20 to 24 is back at 3. 25 to 29 all the way up to 8. And then I don't have anyone again until 45 to 49 comes up to 1. And 50 to 55 to 59 comes up to 1. Now what I'll do, now that I've got those dots on there, I'll use the lines. And connect with the tops again, straight edge. There's 2 of them here at 3, so I just skipped and then went across. And there we go. Now let's do all of the labels on our histogram. So of course the bottom is intervals. The side is your frequencies, so I always turn my paper to write it. And the top is what we're looking at. And we are looking at amount of fat grams in McDonald's items. There's our title of our histogram. Make sure you use a straight edge to draw those bars. Make sure they're touching. Make sure you've labeled all sides. Make sure you have a break in your graph because we did not start at 0. and you should be good to go. Take your time, make sure these two things measure up. Okay, so let's move forward. Another use of our data will be to create a box plot. Okay, so since I have a separate sheet of paper with my data on it, what I'm going to do is I'm just kind of putting this so you can still see the data right here. Okay, so I've got this right here so we can still see the data and we can make our box plot. Now the box plot needs the 5-number summary. So whenever you create a box plot, you must list the 5-number summary out. So your 5-number summary is going to be the min, the Q1, the median, the Q3, and the max. Okay, so let's list those out. Again, even though I know I have them on my paper here, whenever I create a box plot, I have to state them. So I'm restating them as 7, 15, 22, 26. And again, remember, our new max is 29. And right here, I'm going to put an asterisk for my two outliers, which are 48 and 56. Those were my two outliers in my data. So now, given the range of 49, I need to get my 5-number summary on this scaled number line in a box form. So let's see. If I've got to fit a range of 49, and I know I have 21, I'm just going to show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 hash marks on my scale. I come over here and I take 49 and divide it by the 21 marks I've got and see, oh, I'm going to have to go by 3s at the minimum. Okay? I can't go by 2s. I won't fit everything. I'm going to have to go by 3s. So that's the plan. That's what I'll go by. I'll start with 6 and move forward from there. So 6, and then here's 9, and then 12. I'm going to do this so I can fit things a little better, right? And then 15. That way you can actually see a little bit better what's going on each line. 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, and 57. All right, there we are. So there's our scaled number line that'll fit all of our data values, and we'll get our 5-number summary up there. Okay, so let's see, our 5-number summary, the min is 7, so above 7 over here, let's put a little dot. Q1 is 15, so let's put another dot above 15. Median is 22, so that's going to be right about here. Q3 is 26, that's actually right about here, so that's all, 50% of the data is all over there, right? And then our new max is 29. And then we've got outliers at 48 and 56. There are my outliers. Okay. Let's get our straight edge. And what we're going to do is we're going to increase the size of our Q1, our median, and our Q3. And then we're going to build a box around those. So I did make my median line a little bit longer, so I'll connect those in a sec. Okay, there we go. And then I want lines drawn out to the max and the min from the Q1 and Q3 respectively. There it is. Look at that. Look at how much. Now, this is a real good visual as to how much those outliers really are outliers, right? It really is. And then I'm going to show you how to do that in your graphing calculator. Now, your data is already in L1. So if you press second and Y equals, you get to these stat plots. This is where you can plot your data from your L1. So now if I press enter for the first stat plot and then enter again to turn it on, and I arrow down to type, I can arrow over to this fourth option that has a box plot with the two dots next to it. That's a box plot with outliers. And if I press enter, now I'm going to plot from my list one the values that make this a box plot, the 5-number summary, including the two outliers. Okay, so if I press zoom and see zoom stat is number 9, so zoom 9, there it is. And even better, if I press trace, now I get the little spider guy who I can now use the arrows to see. Look at the bottom. It's telling me the Q3. It's telling me the new maximum, right? Now it's telling me an outlier. Now it's telling me an outlier. It's still going to call that main maximum the max, but notice it's not picturing that max the same way on here. It's stopping the max at 29 on here, okay? Because again, it really is the max when those are outliers. And then we can go backwards and check on the min in the Q1, okay? A lot going on here today because we're reviewing basically all of chapter 2 all at once. So what is beautiful about this particular problem and having the scale for the dot plot, I already know what I can do. I can use this scale. Okay, I can use the scale that I've already used from my box plot in order to graph each and every individual data point. So this does take a little bit of time, but at least I know my scale already. And I have an idea where my data is going to fall. So let's fill in the scale. And I'm just kind of going back, filling back in my odds. I did my evens first. I'm just going back and filling back in my odds now, so I know where everything is when I go to plot these data points. And I'm just copying from above. Now I need a dot for every single individual data value. So what I'm going to do so that you can see the data as we plot is I'm just going to fold this down and then pull this down so you can see the data points. And we'll plot each data point. And after I'm done, I'll put a little dot next to it because I've got it on there. Okay? So let's start with the Big Mac, which is 29. So there we go. Dot. I'm doing a second dot there because that's my max, right? So let's see. Then we've got 26. Okay, so that goes right here. And we want to line up horizontally our dots. 23, line up horizontally. 19, line up horizontally. 9, line up horizontally. 22, okay. 27, notice all these are lined up straight across. 25, 29 again. Okay, so since we've got 29 again, now this becomes the first dot that's going up vertically. So you line them up vertically and horizontally as you go. Oh, 26 again. Okay, so since we got 26 again, that one now lines up across with this second 29 as we're going. And 19, that's another 19. Then another 26, okay. Maybe we're finding a mode. 22. Brilliant. 48. Well, this guy is going to get an asterisk because he's an outlier. Then 56. Okay, he's also going to get an asterisk because he's an outlier. 14. 7. 7. 18. First 18. 15. That's the first 15. There's another 15 immediately. And then an 11. And then a 19. Okay, that's my third 19. And then a 25. That's right here. And there we have it. There's our dot plot. So now you can see from a dot plot. So here's the advantage of a dot plot. Now we can see we've got two modes. Those are the two data values used most. And that's one of the things the graphing calculator doesn't show us, right? And our two modes are 19 and 26. They both appeared 3 times, right? Now, with all of this, we kind of look at it and we're supposed to kind of say, oh, skewed, symmetrical, all that kind of jazz. Really, with both of these, and let's just show these two plots. We are mostly symmetrical, okay? We mostly got all the data right here. These are outliers for a reason. They really do not fit with the rest of the data, okay? So when we're answering this question, we're going symmetrical all the way down. And what do you think the typical amount of fat of a McDonald's menu item is? Is it the mean? Is it the median? Is it one of the modes? And this is where you kind of think about that. Like, okay, well, obviously 48 and 56 are really dragging the average up, right? When you've got outliers, it is extremely unlikely that your average is accurate. We got pretty darn lucky here, though, because our average and our median are the same. So actually, either one of these works. So your data was so strongly middled, so strongly symmetrical, that it was able to combat 2 outliers for an average. That's pretty darn good data, okay? So a typical amount of fat in a McDonald's menu item, I would say, would be 22 grams of fat, which is either the mean or the median. It's both, right? A typical deviation from the mean, that is your standard deviation. So your standard deviation, again, was around 11, right? So that means that a typical deviation from mean is take what you've decided to be middle, so 22, add 11 to it, subtract 11 from it. So that means that most of the data lies between 11 and 33 grams of fat. So our typical deviation from mean is 11 grams of fat, because most of my data really does. The vast majority of my data lies between 11 and 33 grams of fat. That is our overall review of chapter 2, all in one lesson. So I know it was a little lengthier, but we had a lot of ground to cover and a lot of reminders and a lot of graphing calculator work. All right, guys, enjoy the homework. This has been your chapter 14 lesson 1 notes, reviewing all your univariate data analysis. Have fun. Good luck. I'll see you for bivariate data. Bye.